All right, so we'll probably finish this chapter 1 or 2 weeks now. Okay, then I want to go to the next chapter. So, amount of moles. Okay, this one just recap. So, there's three formulas. Formula one is mass over molar mass. So, we've done this like a gabillion times already, right? All right, so mass is always in the unit of grams. So it doesn't really matter whether it's a solid, liquid, or gas. As long as it's given a unit in grams, you can use it. Okay? So that is for first formula. The second formula, amount of moles, is volume over molar volume. Okay. This is only for gas, and it's when they give us a volume of gas. So for example, you can be given in decimeter cube or centimeter cube. So for example, let's say they give you in decimeter cube, then your molar volume you must use 24 decimeter cube. If they give you in centimeter cube, then your molar volume you must use 24,000 centimeter cube. It's not the same. Okay, remember 1 decimeter cube is 1,000 centimeter cube. All right. So, all right, there's these two formulas. Okay. So this one is only when they give you a volume of gas. Okay, so today we're going to start formula 3. Formula 3 is not for gas, it's not for solid, it's for something what we call aqueous solution. And the formula for amount of moles is mv over 1,000. M is molarity, V is volume in centimeter cube. Okay, can you write this down first? Okay, so I'm gonna, so molarity is MO. I'll explain to you what it means in a while. Okay, all of you have exercise book, right? Or notebooks, right? Okay, okay. All right. How do you, Jared? Okay, can All right. So imagine you have a beaker with 1 decimeter cube of water. Hello. Okay. I'm so sorry, dear. I forgot your name.
Usually,
Are you joining?
yeah, I joined my last class when I went to the office.
Oh,
Yeah.
did you watch the video?
No, I just finished my robotics stage, so there's a lot of catch up with.
Okay, robotics as in what? You became a robot?
No,
Are you from this school?
yes.
Okay. Lim what? Sorry.
Illusion. X.
Oh. LIM XUAN YI. Okay. Boleh. Like for 5 seconds, I was wondering. Wow. Okay. I'll ask Mr. Kong to add you to the group, and then I'll send you all the videos of the old classes. Okay? Because I think most of the classes I have recorded. Yeah. No problem. Okay. All right, so if I have 1 decimeter cube of water, okay, and I put HCl, okay, I pour in exactly 36.5 grams, okay. It's like I got 1 gram of Milo powder, I put in 1 liter of water, like that, okay. So I can calculate something called concentration. Concentration is the mass over volume, right? Concentration of something is mass over volume. Okay, so the mass is exactly 36.5 grams and the volume is 1 decimeter cube. So my concentration will be 36.5 gram per decimeter cube. You know what this unit means, right? So whether you write gram dm -3 or you write gram slash dm3 is the same reason. Okay? Can? All right. So this is how we calculate something called concentration. Okay, can you write this down first? Hi, Jacqueline. No, not yet. We are doing, yeah. I mean, later we do something new lah. We do new paper. They are writing notes. Actually, they are writing notes. Exercise notes. You have a notebook? Yeah, okay. Done, guys? Done, huh? Okay, now. Now, I need to see how much you remember. Jai, you okay? Can? Okay, so, very important question. Can you please tell me in 36.5 grams of HCl, what is the number of moles? Can you please turn this 36.5 grams of HCl into mole? Okay, you look here, you got formula 1, formula 2, formula 3. Which formula should you use? Okay, do it now. Look at your periodic table. I give you periodic table last time, right? Yeah. I give you periodic table last time, right? Yeah, okay, good. You might take some time to catch up because this is already like the fourth or fifth class for this particular topic. Okay. All right, Ken, how much? One, yes, thank you. I will sit down and cry if you all don't know it's one. Okay, because hydrogen is one, chlorine is 35.5. So HCl is 36.5 gram per mole. So if I have 36.5, 36.5, 35, 36.5, I got 1 mole. So my concentration, another way of calculating my concentration can also be calculated as amount of moles over volume. And that gives me 1 mole per decimeter cube. Okay? So I want you to look at this question only. Is 1 mole per decimeter cube the same value as 36.5 gram per decimeter cube? Is it the same value? Yes. It's as if like $1 and 4 ringgit. So I'm telling you, these shoes are 10 ringgit. So expensive. These shoes are 10 US dollar. So expensive. These shoes are 44 ringgit. So cheap. It's actually the same, right? Or not? Okay, so let's say one US dollar is 4 ringgit. It's 14 ringgit, same thing. So the value is the same. It's just different unit. Okay, but this is called concentration. This is also called concentration. But then I'm going to get very confused. How I know which concentration you're talking about? So when I use the unit of mole per decimeter cube, we call this concentration molarity. So therefore, molarity means M. The symbol for molarity is M. Okay? Okay. Can Now, so remember we got three formulas. Okay, so these three formulas very essential. Please staple them into your brain. Okay, MV over 1000, mass over molar mass, and volume over molar volume. So now we are only going to use MV over 1000 for now. Okay, because we're using aqueous solution. Okay, so like this in school, in labs, they're not going to give you diluted. You buy Ribena in the shop. Is it diluted Ribena or concentrated Ribena? The big bottle, concentrated lah. You're not supposed to take that and drink. You're supposed to take it home, dilute it and drink. The same concept in your school lab, you'll be given a big bottle of hydrochloric acid. This will be HCl, 1 mole per decimeter cube, and it'll be one big bottle. We're not going to use all. We're going to take out some to use. So let's say we pour it out into a beaker. We take 25 centimeter cube of hydrochloric acid, which has the concentration of 1 mole per decimeter cube. So in this hydrochloric acid, how many moles of hydrochloric acid there are? So we look at this, formula 1, formula 2, formula 3, because it is an aqueous solution. Do you know what's aqueous solution? Acid, alkali, salt solutions. Every time you see this unit, mole per decimeter cube, you know you have to use this formula. Amount of moles is MV over 1000. Okay, can? So M, molarity is what? V is 25 over 1000. So it's 0.025 mole. Okay, 0.25. Correct. 0.0. Sorry. 10. Can you understand? You get it? Okay. Okay. Can? So now, can I combine all three together? Can, right? Okay. Did you get the notes when you came 2 weeks ago? Did you get paper? Do you have it?
I don't think so. Not all this is from me.
But this letter I did 2 weeks ago though.
Come 2 weeks ago.
Like long 3 weeks. Okay, okay. All right. Never mind, today we use this one. Okay. If you guys did the old paper, you pass it up to me lah, then I'll mark for you. Okay, let's do this. Okay, sorry. Before that, let's try this. Let's try this. Okay, so now it's like this. So if I have uh how do I know it's an aqueous solution? So they will say things like the words solution, they will say things like acid, alkali, and obviously they will have this unit. Okay, can pass it up. Okay, so we're gonna use this paper now. Okay, so using this, you pass it to them. Oh, it's okay. They all always bring their food and eat because it's lunchtime. Okay, let's start warm up with the easiest question. Okay, look at the first page. 94. There, 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 there. Who is this? Ariel. Ariel, your friend. What person who are? Oh, Ejin. Ariel, Ian, Ejin. Okay. All right, let's do number one. Easiest one. Easiest one. Just warm up question. Okay, how much? Which one? How much, but which one? Ammonia is not NH4. Ammonia is NH3. Remember, NH4 positive one is ammonium ion, right? Okay. Carbon monoxide is not CO. CO is carbon dioxide. Carbon monoxide is CO. CO2 is carbon dioxide. Iron 3 oxide means, okay, this one, iron 3 oxide means iron 3. Oxide is O2 negative. So 3 positive, 2 negative, you move it around, it's Fe2O3. Okay, so obviously the answer is who? D lah, okay, why is it D? Zinc is 2 plus, hydroxide is OH negative. So 2 plus and negative 1, can you cross? Yes. So you get ZnOH bracket 2. Okay, do you understand? Okay, can you try 95? Same concept. This is really like thinking back, everything we learn. Okay, which one? D, yes. Okay, ammonia, yeah, I told you already, ammonia is NH3. Carbon dioxide is CO2. Okay, why is this one wrong? Potassium is K or P? K. So it should be K2O. P is what? Oh, phosphorus. Okay, P is phosphorus. Teacher, am I supposed to memorize this? That's why you have the periodic table, but you kind of need to know that you can't be looking. Okay, you have 40 questions in your paper too. You can't be looking for the periodic table for every single question. You only got 45 minutes to finish it. You get it? Okay. Okay, last one. You can do this and we do something else. Okay. What's your answer? Yes. A, B, C, D?
E.
B. Okay, this one should be NH4Cl because I already told you. Okay, silver nitrate. Silver is 1 plus. Nitrate is 1 negative. Okay, remember the list of ions that I taught you the first few classes? Okay, you have to memorize that. 1 positive, 1 negative, you cancel each other out, you get AgNO3. Okay, why is this correct but this one wrong? Sulfide is S2 negative. Sulfate is SO4, 2 negative. Copper 2 means Cu2 plus. So Cu2 plus S2 negative, you can cancel each other out. So Cus. Get it? Okay. What would be the formula for iron 2 sulfide? Using the same concept. FeS. No, because Fe is 2 plus, S is 2 negative. Cancel each other out now. FeS. Same concept. Get it? Okay. Okay. How to do this? How to do 1997? The only way to do 97 is you have to write down all the formulas. Okay. So let me just give you a hi, Jean.
Sorry, so today my tuition teacher like telegram email stuff. Yes. Yeah.
Okay, it's okay. What class did you have just now?
Oh, so now what's this?
Today's one. But nobody can beat Ariel. Ariel is still the latest. All right. Now, let me give you the list. Okay, remember, everybody in group one is positive one. For example, potassium, sodium. Everybody in group two is positive two. For example, magnesium and calcium. Everybody in group three is positive three, aluminium. Okay, these are the easy ones. You can look at the periodic table. The ones that are not so easy is the ones that you have to memorize. So the ones that are from transition element. So if they say copper 2, then it's Cu2 plus lah. If they say iron 2, then it's Fe2 plus. If they say iron 3, then it's Fe3 plus. Tin, they won't, silver, they won't tell you silver 1, silver 2 because it's only Ag plus. Zinc also, they will just tell you Zn2 plus. They won't tell you it's zinc 2. Okay? So these are the common ones that we see. Of course, there's also lead 2 and lead 4. Okay. Everybody in group 5 is negative 3 because they are all trying to achieve 8 full outer shell. Everybody in group 6 is negative 2, oxide, sulfide. Everybody in group 7 is negative 1, chloride, bromide, iodide. Right? Okay, using this concept, please do this now. Hurry up. Write all the formulas and tell me what's the answer. Jia Yi, you got an answer? Not yet. Okay. Try. Okay, calcium oxide. Calcium is Ca2 plus, oxide is 2 negative, so CaO, right? Copper oxide, copper 2 oxide, CuO. Iron 3 oxide will be Fe2O3. Potassium oxide will be K2O. So when written as a formula, which compound has the greatest number of oxygen atoms? Your answer will be C. Get it? Okay. Do you remember ionic compound? Remember how to do it? Too bad. Okay, please do. 98 is ionic, 99 is covalent, 100 is ionic, and 101 is ionic. Okay, please do this page now. Try. Same concept, okay? Now you know what group it's from, right? You see, this one, 1, 2, 3, 4, 5, 6. 6 in the outer shell, 6 electrons in the outer shell means it's in group 6. So group 6 means it will form 2 negative. Okay? So this one, outer shell only has 1. That means it's in group 1. So group 1, it will form 1 positive. Okay, when you want to form an ion, what we usually do is we put the positive first and the negative second, and then these numbers, if they are not the same, we swap. If they are the same, we don't swap. Okay, so positive and positive 1 is the same thing. So it's 2, so we swap. So it's Q2P. But this one is trying to be smart, so they just terbalik. So it's P, Q2. So the answer is P. Get it? Make sense? Right. Wait, 99. This one just count. This one is literally like Lego like that. Okay, so do the other three. Okay, ready? So how many carbons do you see? 2 carbons. So C2, H3, Cl. Can see? C2, H3Cl. Okay. Alright. Compound containing 1 atom of calcium, 2 atoms of hydrogen, and 2 atoms of oxygen. Okay, 2 calcium, 1 calcium, 2 has. Salah, D lah. Okay, make sense? Alright, this one, this is, remember I told you the swapping thing? So Fe 3 plus CrO for 2 negative. So 2 and 3, you swap the space. And then because Cr is one element, O is a different element. So CrO4, you need to bracket 3. Fe2. Okay? Make sense? Okay. So let's just have a quick look at our 3 formulas. Okay, you were not here just now, EJ. We did a third formula. So there are 3 formulas. Always remember. Okay, get a tattoo of it if you can. Mass over molar mass is formula 1. volume over molar volume is only for gas, formula 2, and MV over 1000 is the third formula, only for aqueous solution when they give you molarity. Okay, so let's try and do it as a mixture. Okay, let's try. Okay, let me find an easier question first. Mm, mm, okay, the only one is here lah. Okay, I'm trying to find something easier. Okay, all look at 129. Question 129. Let's say it's all silent lies. In sense, let's say you kind of lies, you ask me the dress. So the three formulas, you see dress. One first finger, mass elements. Okay, so what is the mass of first? You see six, you come for six, you get you see six, inches, 12 ounces. Something plus hydrogen 12. So hydrogen one nitrogen plus oxygen 6. So oxygen 16. So you take 12 times 6 plus 12 times 1 plus 16 times 6. And you only get moles. So then you get the heat over the molar concentration. Can you remember how to do you remember how to do molar mass? 12, hydrogen is 1, oxygen is 16. So it's altogether. So they 12 times 6 plus hydrogen 1 times 12 and then oxygen 16 plus times 6. You add together the mass, this one, mass over that mass. Okay. Oh, how do you pass it to him? Okay. No, no, no. Ian, your friend.
Oh, yeah.
Who same class with Ariel? No, you.
Probably not.
Okay. Okay, so they give you gram. So which formula you use? 1, 2, or 3? 1. So you must, okay. Teacher, do I need to write down the formula? Yes. Why? Because I am the one who remember the formula. You need to be the one who remember the formula. I promise you, you write it down one more time, won't die one. Okay? Mass is 30 grams. Molar mass, so you look at C6H12O6. Carbon is 12 times 6. Hydrogen is 1 times 12. Oxygen is 16 times 6. You get 180, ah?
You know what I mean?
Okay, so 30 over 180?
1
1 over 6, ah? They need decimal for IG.
0.1.
0.167 lah. Okay, so get it? IG must put decimal lah. Why? I don't know. No, I do one. Okay, it's put decimal. Okay, look at this equation. Look at this equation, ah. So this equation is telling you glucose, this is glucose, reacts to form ethanol and carbon dioxide. This formula is ethanol. Okay, now what you need to do is you look at the numbers in front. In front of this glucose, any number? No, so that means it's 1. In front of this ethanol, there's a number, the big number, yeah, so the number is 2. So that means for every one of this, I will make 2 of this. That's what the numbers mean. For every 1 mole of glucose, I make 2 moles of ethanol. So if you tell me that I have, uh, glucose, 2 ethanol, the ratio is 1 to 2. Okay, yeah? Go. The ratio is 1 to 2. So if this one is 0.167, this one is double or half? Double. So you get 0.33. Okay. No, you cannot just press calculator magic like that. You need to, I know what you mean. You have to put 0.167 times 2, 334. You understand that? Because you got 0.1666 and then straight away press times 2, right? You cannot do that. You have to bring forward. Because you bring forward this value, must bring forward your value. You cannot press calculator, this is the problem with not only you, all of you guys with this, because you're so used to calculator, you don't know the working is important. You have to bring down the correct number. Get it? Okay, so this is the amount of moles. 0.167 mole of glucose gives me 0.334 mole of ethanol. Get it? But are they asking you the mole of ethanol? No, they're asking you the mass of ethanol. Okay, so if moles is mass over molar mass, then mass would be moles multiply molar mass. Do you have the moles of ethanol? Yeah, 0.334. Do you have the molar mass of ethanol? No, but can you find it? Yes. Okay, so moles times molar mass. Moles is 0.334. Molar mass of C2H5OH. Carbon is 12 times 2. Hydrogen is 1 times 6. Oxygen is 16. 46, right? Okay. So 15. Do you understand?
Yeah.
Can?
There's no place
Actually, 2 decimal place enough lah. It's okay, yeah.
for sure out for one of where we shall
You forgot to what?
be back first is
If you need to watch the video, okay. Calculate the volume of carbon dioxide. Okay, volume of carbon dioxide. Is carbon dioxide a gas or an aqueous? Gas. So which formula do I use? 1, 2, or 3? 2. So if amount of moles is volume over molar volume, then I'm looking for volume. What is it? Moles multiply molar volume. Get it? Alright, so volume equals to moles multiply molar volume. So moles is where am I? Oh, what is the moles of carbon dioxide? What is the moles of carbon dioxide? The ratio is 1 to 2 to 2, right? So is it 0.167 or 0.334? 0.334. 0.334 times molar volume is 24. Okay? Can make sense?
yeah.
Okay. please try. Okay, let's just look at this question first. Read the question first and tell me what you think. Which formula and which you do. What in the world are you eating? Okay, come on. So the molar mass of MnO2 is 55 plus 16 times 2. Huh? 87. Okay. So mass over molar mass, amount of moles. Write down the formula. Why? Because you will forget if you don't write down. You won't know how to do revision. Mass over molar mass. Zero point zero 0.04. Okay. MnO2 to HCl. What is the ratio? 1 to 4. 1 to 4. Get it? 1 to 4. So do this and do this. I will give you a clue for this. Amount of moles is mv over 1000. I give you a clue for this. Okay? And this one, just use the ratio. There, 1 to 4. Okay? Do it now. Quick, 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 quick. That's what? Ratio. Use the ratio. MnO2. This one, this one. This one, MnO2 to HCl is 1 to 4. I'm just writing the same thing here. You can manage to get something? Did you manage to get an answer? Okay, please tell me you at least got this. What's the answer? 0 point? 0.156. Okay, so this is the amount of moles. This is 0.16. You are looking for V. Volume is V. Do you know M? Yes, there. 8. They give you in the question 8 times V over 1,000. 20 centimeter cube. Do you understand? Look first why I'm using this formula. Because they give you the molarity of acid. There. This value here, 8 mole per decimeter cube. This is the M in MV over 1,000. Get it? What is what? Volume. V for volume. MV over 1,000. Whenever they have an aqueous solution and they have molarity, you use this formula. Okay? Can? Can understand or not? Okay, look at the formula first. Yes, yes. Done? Done? Everyone done? Okay. Look at this question. Okay, I give you a clue. This one only use Formula 1 and Formula 2 and ratio. Okay, try.
Which of the answers for the one again?
20.
I feel like student understand
Which one?
question.
Why? Which part? Which part? You're using the formula, because there's 3 formulas. You're using the formula amount of moles is MV over 1,000. The question is asking you for V. Okay? Because it's a copper to nitrate. Count lah! Take out your periodic table and count. So this question is asking you for V. You have M. The question gives you M there. This is M. So it's algebra only. You're looking for the unknown. Make sense? Ah. That's all. Right. Copper is 64. I will kill you, ah. Copper is 64. Nitrogen is 14. Oxygen is 16. Quickly, quickly, quickly. Take the big one, of course. Huh? Use your phone. Why you don't bring calculator to class? Mass of 1 mole is molar mass. Done? How do I calculate this? Formula 1, 2, 3? What? 4.7 over 180. Okay? Okay. Now, question is asking you nitrogen dioxide. Which one is nitrogen dioxide? This one. The ratio is 2 to 4. Can you see why? Here is 2, here is 4. Okay, so CuNO3 to NO2 is 2 to 4. Is 2 to 4 1 to 2?
Yeah.
Yeah, so what do I need to do? Times 2 lah. So from here to here times 2. So 0.05. Okay, if you don't know how to do this, look back at just now that question. Which formula do I use? 1 or 2? 2. So amount of moles is volume over molar volume. I am looking for the volume. If you miss class or parts of class, you have to watch the video. If you do not watch the video, you cannot catch up. Okay? So the volume will be 0.05 times 24 to 1.2. Okay. Ken, do you understand? Get it?
Yes.
Yeah? Okay. Go back up, go back up, go back up. Alright, do look at question 1 to 8. This is a bit more challenging. Can you try? This gives you volume. This is a gas. Which formula do you use?
Second.
Second one. Okay. Use the second formula to do this first. Okay, done? Doing. Okay. What's the first one? So this one, right? So amount of moles of carbon dioxide into volume over molar volume. We do formula 2. So volume is 0.24, 0.01, right? Okay. See, okay, this question is a little bit more complicated. So they're telling you there's a tablet. The tablet will react with hydrochloric acid the same way to produce the same amount of carbon dioxide. So in the two equations together, if this one is 0.01, the total of these two, are they the same? 0.01? Yes, because the ratio is 1 to 1. So the number of moles of calcium carbonate and magnesium carbonate is 0.01. Get it?
Oh.
But if I only take calcium carbonate, divide by 2 lah.
Wow.
0.005. They're telling you the tablet got two things. The total gas is come out. So the total amount of the tablet is how much? So now I only want half of it. How much is it? Half of it lah.
Yeah.
Try and do this. They give you the sequences already. You just have to do. You just got to follow the sequences. Don't just wait for me. Try. Jai, try. Okay. Number of moles of calcium carbonate and magnesium carbonate, there, 0.01. So number of moles of hydrochloric acid is, what's the ratio? 1 to 2. So 0.02. Get it? Okay, this one, same concept. Moles is mv over 1000. Who am I looking for? Volume. Who am I looking for? V. Okay, find answer. Quick. Okay, what's answer? 0.02. M is 1 there. 1 mole per decimeter cube. This is M. So 20. Okay, 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 okay. Have a few moments.
She can have one.
Yeah. Hey, it's not raining inside the classroom. Don't need to put umbrella now, is it? Can you understand? Get it? Okay. What question is this? 135. What question is this? Empirical formula. We did empirical formula last week. Empirical formula, all you need to do is take these percentages, divide the molar mass, and find the ratio. Remember? I wish when I say remember, you're all staring at me. What are you talking about? Carbon, hydrogen, oxygen. First, you find the amount of moles, then you find the ratio. Okay? You take this as mass. Mass over molar mass, mass over molar mass, mass over molar mass. Carbon is 12, oxygen is 16, hydrogen is 1. Do it now. Hurry up. Yes. Okay. Mass over molar mass, mass over molar mass. Carbon is 12, oxygen is 16, hydrogen is 1. Okay? We're calculating what is the percentage in each. Okay. Yes. Are you serious? Okay, so this one 4.05, 8.11.
0.50,
2.70. Okay, what do you do after that? This is amount of moles, huh? Okay, in order to find the ratio, you find what do you do? Divide the smallest number. You find the smallest ratio by finding the smallest, divide the smallest number. Who is the smallest number in all three? 2.7. So you take everybody, divide 2.7025. You will get 2, 4, 1. So your formula is C2H4O. 1 no need to write. Can you remember?
Okay.
Okay, how empirical formula means the smallest ratio, the simplest ratio. This molecular formula means the actual amount. How do you change empirical formula to molecular formula? You multiply. Basically, is C4H. You already know it's C4. This okay. This is a different question. They tell you the empirical formula is C4O, CH4O, right now, and the molecular mass is 32. You need to know how many times bigger this is to this. First, you calculate CH4O. 12 plus 4 plus 16. How much is this?
26.
32.
Oh, wow.
So,
Oh, my God.
is the value the same? Is the value the same?
Yeah.
If the value the same, the empirical formula is the same as the molecular formula. If it's not the same, then you multiply how many times bigger it is.
My God.
Get it? Okay, do 136 now. Now do 136 now. Please go home and study. Please go home and read through the videos again. Ah. When you finish with this, do the other two questions. Okay, the last for 20 questions. Okay. Okay.
Don't answer me. So, I'll fully master over. Someone got here, totally. That's
How did you get this? You divide.
Square pages.
Correct. Correct.
Square pages.
Yeah, correct. Yeah, after you got this, what do? Divide the
It's but like the 4.9 divided equals 0.5. You can do that.
4.9 divide 1.9 equals to 2.5.
And then
Wait lah, you write 2.5 first lah. So you divide everybody with 1.96, right? Yeah. Okay. You divide everybody with 1.96. Correct. You get 2.5 and then
5 and 1.
5 and 1. Okay. I taught you last week, literally last week. When you get 0.5, what must you do? Times 2 lah. So you get C5H10O2. Got it? Okay, so this is empirical formula. Okay. Okay. Same concept here. Wait, this one also C5?
I know.
135.
Yeah, so wait, the answer is C3.
Wait.
After that, it'll be more original.
Oh, is it?
Yeah, it's question 134.
Oh, it's question 135. Oh, this one. Oh, C2H4O. Eh?
You the answer. Yeah, so,
Oh,
the
no.
answer is different.
Wait. Wait. Okay. Let me count.
How? Same thing. So,
48.65. 8.11. Eh, same oh. 43.24.
Yeah. You can't browse.
Oh, no. This one is eh?
So that's system, right?
We get. Did you count something wrong? Ah, same ah.
What is the answer different?
I think you counted wrong. You look and see carefully. Correct. 2.7, right? Ah, correct lah. Same lah. 241 lah. Same. 241. Sorry, Jin, I didn't see properly your answer. Eh?
Or is it the answer?
Oh, no. I understand why. Just now, I think I clicked wrongly. I saw this as 2.1. My mistake, guys. Both this one. Yeah, I divided 2.7, but I divided wrongly. Yes, I divided 2.7, but I think I didn't press it in. Can you please change the answer here? 135. Can you please change the answer? I put here divide 2.7, right? If I divide 2.7, I shouldn't get 2. I think I pressed 2 instead of 2.7. Or I pressed 2.1 in my calculator.
So what?
4. Yeah. You're right. You are right. 4.05 divided 2. No. 4.05 divide 2.7 is 1.5. Just now I pressed in my calculator, I pressed 2. I didn't press the. Yeah, it's the same thing, but the answer is wrong because I calculated wrong just now. Can you understand now? So this 1.5. Can you please change this up? 135. 8.11 divided by 2.7 is 3. And then it says 1. So it should be C3H6O2. Okay? I think when I was pressing my calculator, it came out as 2 because I wrote here divide 2.7. So both answers are C3H6O2. Ah. Make sense or not? Okay. Please study